So the integrating factor is given by e raised to integration of p. Here in the denominator we have dy, so dy. So remember, whenever we find integration for type 4 problems, whatever in the denominator we used to have integration of that, so into dy. So integrating factor is e raised to integration of p dy. Our p is -1, so integration of -1 dy. So what is integration of -1? Integration of -1 is nothing but y. So e raised to -y. So this is our integrating factor. When we have a linear equation in x, what is its solution? So its solution was x into integrating factor equal to integration of q into integrating factor into dy plus c. So this was the solution for linear equation in x, but we have linear equation in u. So this part will remain same, but instead of x we will have u. So u into integrating factor equal to integration of q integrating factor, and this part will remain the same. So what is u? So we have substituted u as x into e raised to x. So u is x into e raised to x. What is integrating factor? Integrating factor we have calculated as e raised to -y equal to integration of q. What is q? Q is -y e raised to y. So q is -y e raised to y into integrating factor into dy plus c, which is equal to, I can take this minus sign out of integration, and e raised to plus y and e raised to minus y is nothing but e raised to 0, which is equal to 1. So we are remained only with y dy plus c. So what is integration of y? Integration of y is y square upon 2 plus c, and this part will remain as it is. So this is the solution of this problem. So what is the logic behind this type of reducible to linear differential equation? So I am going to teach you something. So this is the linear equation in y, where p and q are functions of x or they are constant. So in this case, our integrating factor is e raised to integration of p. If the equation is either in this form, our integrating factor is e raised to p. Only here will change dy or dx. Whatever is in the denominator will come here. Okay, so here in the denominator it is dx, so it will be e raised to integration of p dx. Similarly, for linear equation in x, we have this term where p and q are function of y or constant. So this is the linear in x. So our integrating factor is nothing but e raised to integration of p. Here in the denominator it is dy, so dy. Since it is a linear in y, so the solution is given by y into integrating factor equal to q into integrating factor dx plus c. So since this is a linear equation in y, so our solution starts with y. This is the linear in x, so our solution will start with x. Other part will remain the same. Since here we are using dx, so in integration also we will use dx. Here we are using dy, so here also we will use dy. Now you can remember any one equation and rest will remain the same. Similarly, we used to do for du by dx and du by dy. So this is the linear equation in u. For this case, the integrating factor will be e raised to integration of p, and here we write whatever in the denominator. So in the denominator it is dx, and the integrating factor will be similar to y, because here these two are same. Here it is y, here it is u, and these two are same. Here it is x and here it is u. Okay, so if you remember all these things, you can solve any 4B type of problem. Okay, so more such problems we will see in our next video, so stay tuned for our future lectures.